Hi everyone, I'm Eric from Mirantis. In today's on-demand webinar, we're going to walk you through the setup process for a web app built on Node, React, and MySQL to be deployed as containerized services. Our goal here is to be able to work on this application with our front-end, back-end, and database all running in containers, so we can build out our app and then smoothly deploy to Kubernetes or Docker Swarm. Big picture, we want to make cloud-native development easier, so you can focus on your app itself. This walkthrough is intended as a hands-on lesson for beginners to cloud-native development. We'll be working with the Docker engine, and we'll be pausing frequently to talk through the commands we're using. By the end, you should feel confident getting started with your own containerized app using these components. Along the way, you should get a solid primer or refresher on container concepts like volumes, port forwarding, and networking. If you'd like to follow along, you'll need the Docker engine installed and running on your machine. On Windows or Mac, that will probably mean you're using Docker Desktop. It'll be helpful to have a basic understanding of the Linux command line as well, but you should be able to follow along regardless. Before we jump in, a few details about me. My name is Eric Gregory, and I'm Senior Technical Writer at Mirantis. I'm the author of Learn Containers 5 Minutes at a Time and co-host of the Radio Cloud Native podcast with Nick Chase. In a past life, I was a computer science instructor, and today I write on Kubernetes, containers, and other topics in the cloud-native space. So, if we're setting out to develop our app as a set of containerized services, those services will need to be able to communicate with one another on a network. So we'll start by creating a user-defined bridge network where our containers can reach each other by DNS. I'm going to imagine I'm building just a template app here, a test app, so we'll name its network accordingly. So what exactly is happening here? We're creating a new network named testnet, and we're using the D, or driver, argument to specify that it should use a particular model for the new network. The options here are bridge, overlay, or a custom driver option added by the user. Bridge networks allow containers within the network, all of which must be on the same Docker daemon host, to communicate with one another while isolating them from other networks. Overlay networks allow containers within the network, which may be spread across multiple Docker daemon hosts, to communicate with one another while isolating them from other networks. This driver is used by Docker Swarm for container orchestration. And custom drivers allow for custom network rules. If we didn't create and specify a new network for our containers, they would live on the default bridge network. And when containers are on the default bridge, they can't communicate by DNS. Instead, they need to know one another's specific IP addresses to transmit data back and forth. When we have a group of containers that need to communicate, instead of using the default bridge, we can place them in their own user-defined network. While this isn't the only way to let containers communicate, it is the Docker preferred way of doing things, since this creates a precisely scoped layer of isolation. So now we have our user-defined network. Since we'll be running a MySQL database, we'll also need a volume for persistent storage. Our containers themselves will be super ephemeral, but we want our database configuration and app data to last beyond the lifespan of any particular container. Volumes give us a way to do that. We'll see another approach in a few minutes, but in the meantime, let's create our volume. So now we have a network, and we have storage. Let's create a container to make use of them. Our first container will run the MySQL database. All right, let's break down this command. We're using docker run to start a new container, and we're naming it test_MySQL. The network argument specifies that the container is going to use our user-defined testnet network. The v for volume argument says that the container will use our new volume and associates the volume with the directory in the MySQL container where it expects to be able to save persistent data. The d argument means we're going to run the container in detached mode, which means the container process won't be bound to our current terminal session. We'll be able to keep working rather than just watch it run. The E argument specifies an environment variable, in this case, a root user password for the database. I'm using the password Oktoberfest here. Finally, we're building from the official Docker Hub image for MySQL. All right, now we have our containerized database running. We have 2 more services to go, and both are ultimately built on Node.js. Our backend is going to be a simple Express server, while our front end is going to use the React library. For this setup, we're going to assume that we want to be able to use code editors like VS Code on our local machine. but we want to run Node from containers. So let's set up a simple project directory on our host machine. I'm going to create an overall project directory called test demo. This is where we'll be working from here on out. Inside the overall project directory, we'll create a new directory for the Backend app. Next, we're going to initialize our projects with Node, which means we're going to use the npm package manager to create some core configurations and download packages we'll need for our app. We could do this with a version of Node running on our local machine, but we're not going to. Instead, we're going to keep things really simple and clean and consistent by running our setup from a Node container. Now, in this command, we're going to run Node from the official container image on Docker Hub. There are a few details we should point out here. The IT argument means we're running this container interactively, so we can start a bash session inside. We're using the mount argument to connect the container directly to our hard drive, and we're telling it to start the mount at our present working directory. This is the overall project directory. We're also telling Docker to map that directory to user/source/app inside the container file system. The W argument defines a working directory inside the container, so that's where we'll land when we actually run this. So let's go ahead, and here we are. We're at the working directory that we defined. Now here inside the container, we can use ls, and hey, there's the project directory that we created. Perfect. Now that's our actual directory, our actual test app directory, not a copy. So anything we do here will be reflected on the host machine. Let's hop into our app directory. And since we're inside a Node container, we can initialize the project with the containers instance of npm. This is going to set up our package.json file. We should also install the MySQL 2 driver so our backend app can connect to the database. Note that we're using the MySQL 2 driver. That's important. You'll hit errors if you try to use the vanilla MySQL driver. We also want to use the Express web framework, so we'll go ahead and install that now too. That's all the setup we need to do on the backend side, so we'll head on over to the overall project directory. Here we're going to run a bit of npm configuration to help React get going without any errors. Then we'll run npx create React app test client, which will create a new folder and populate it with files for our React project. Okay, that's it for our initial setup. We can type exit to exit out of the container shell session. If we check the project directories through our host system, we'll see all the new files we've created. Now it's time to build out the foundation of our application. We'll start with the backend. Create a file called index.js in the test app directory. I'm going to go ahead and do that with VS Code. Okay, so up top we've declared a dependency, the MySQL driver. Then we've defined our database connection with our credentials. A couple things to note here. We'll be able to use the host name of the test MySQL container, and that'll resolve just fine via DNS. That's a nice model that we can scale pretty easily when deploying to a container orchestrator. Make sure to be careful of your passwords though. We're keeping things simple here for the sake of a quick walkthrough, but in practice you'll want to make sure to use secrets and to be sure that sensitive passwords aren't hanging out in the open on Git repositories or what have you. Alright, next we're connecting to the database and basically just checking to see if everything is working properly. If the connection succeeds, we'll generate a confirmation message in the console. If it fails, we'll throw an error. Okay, let's see if this works. With this command, we're running a container based on the Node image again. We're running on the testnet network and mounting the hard drive as before. We've added the --rm flag, which will automatically delete the container once it's stopped, and we're going to use Node to run index.js. Let's give it a shot. As you can see, everything is working nicely. The containerized app connected with the containerized database. But we want to take our app template a little further and bring in the front end. So in another terminal tab, we'll stop the test app container. This is going to take a minute to stop, but let's go ahead and add a little more logic to our backend now in VS Code. Now, we've added the Express framework as a dependency. Using Express, we've opened port 3001 for traffic and created the bare bones beginnings of an API. In this case, we're simply answering calls to the API with the results of our database connection. Let's save these updates and then we'll run the backend on a container again, this time with the detached flag and some port mapping. Since we're mapping the container's port 3001 to localhost, we should be able to check out our API at localhost 3001. So let's bring a web browser over. Great, we have our JSON message that we wanted to see. So that's 2 services down. Let's turn our attention to the front-end client. We can test the container with Now this is going to take a minute to start up, but once it gets going, the React front end will be exposed on port 3000, which we've mapped to localhost 3000. Perfect. Everything is running, and as it says here on the default landing page, we'll want to edit app.js in the source folder in the client directory. So let's open that in VS Code and make a few changes. Now, we haven't changed too much here, really. What we've added is a way for this front end to fetch a JSON message from the API and then pass it on to the front page. But there's one wrinkle. There's no API running here. This is a dedicated front end service. To deal with that, we'll open the package.json file for the client, and we'll add a line establishing a proxy at test app port 3001. All right, with that, our pieces are in place. Let's save and run everything here. So this is going to start up our client in its container. We're running in detached mode, so we're not going to see the output, and it's going to take a minute to get going. So we'll wait a second. We'll probably fast forward ahead a minute or two to when our client is running. And voila! We have 3 containerized services all linked up and ready to serve as a foundation for whatever you create. This is obviously just the skeleton of an app, and there are all kinds of quality of life improvements that we probably want to add. But there's one major efficiency we should definitely talk about, and that's Docker Compose. You're not going to want to have to launch all of these services independently with a bunch of unwieldy arguments every time you work on your app. Fortunately, we can create a Docker Compose file that does all of that for us. First, let's save the current state of our container images. With our images saved locally, we'll stop the current containers, and they should be removed automatically. Now, in the test demo directory, we'll write a YAML file that contains all the configurations we've used for each of our containers, and we'll go ahead and do that in VS Code as well. Let's walk through what's happening here. We're declaring the volume and user-defined network that we've been using, which here are defined as external, which simply means that they're outside the scope of the Docker Compose file itself. Typically, the Docker Compose file is going to assume that it defines its own scope, and wherever you've defined a volume or a network, it's going to create a new one. But here, let's just use what we already have. So we're bringing in our testnet and test data, and then we're using them across our different containers as we've been doing. We are defining all the different configuration details, our ports, our network that we're going to use, our working directories. We can define all of this in the compose file. Now, when we have our YAML file here saved as docker-compose in our project directory, we can simply run docker compose up. And there we go. Our app is up and running, and we can bring up our containers with a simple docker compose up command. And if we wait a minute for our client, we see that everything is running perfectly. And that brings us to a close for today. I hope this has been a useful introduction or refresher to the concepts underlying containerized services deployment. If you'd like to play with any of the code from today, you can find it on GitHub at github.com/ericgregory/testdemo. If you'd like to review any of the concepts here, you can check out my free ebook from Mirantis Press, Learn Containers 5 Minutes at a Time, which is available at mirantis.com/press. Thanks so much to the CNCF for the opportunity to give this walkthrough, and thanks to all of you for joining. Take care.